Hey everyone, welcome back. Today we're diving into the world of ray tracing, and I'm rebuilding my old college project from the ground up. I dusted off my old college project, a ray tracing engine built with metal, and tried to run a dynamic scene. Turns out it totally crashed. Apple has deprecated all MPS-based APIs it depended on, which broke the whole thing. Plus, my code from back then wasn't exactly stellar. Instead of trying to fix the mess, I'm thinking it's better to just start over fresh and build it right this time. Let's get started by creating a new project. I plan to build this for Vision OS, Mac OS, and iOS, so we're going with the multi-platform option. We have a basic app. I'm really curious to see how the app looks on Vision Pro. Vision OS is visually stunning. Even in the simulator, it's incredibly impressive. I can only imagine how breathtaking it must be on the actual device. Time to clean house. We're deleting all the default code and setting up a metal view. This is where we'll be rendering our ray tracing magic, but first, we need to figure out how to insert a metal view in SwiftUI. After surfing the web for a while, I came across a sample project by Apple that embeds a metal view in a SwiftUI app. This should help. Let's download it and see how it works. Yes, of course I trust the project. It's from Apple. Turns out, the code from that project is surprisingly similar to what we need. We'll be using a custom class ViewRepresentable, which inherits NSViewRepresentable or UIViewRepresentable to bridge SwiftUI and Metal. We will use the compile time flag to have different implementations of this based on the platform. Adding the compile time flag along with macOS gives compiler error, so I guess Vision OS is more similar to iOS than macOS. The ViewRepresentable takes in a render object for rendering the contents. Alright, so we'll grab the renderer from that sample project as a starting point, kind of like a template. Then, we'll dive into what our app actually needs, figure out what's different, and tweak the renderer. Let's create a file to initialize the engine. I am going to make the properties and functions inside this static, as it would be shared across the app, and would also make it easier to access the properties. I will add the MTL device here. I think I will keep the command queue inside the renderer. To streamline engine setup, we'll create a static initialization function that will be invoked when the app is launched. This function will serve as a central point for instantiating core engine components. For now, we'll just initialize the metal device here. I'm making the renderer a protocol so we can add different rendering modes later, like a basic solid renderer, another for material preview, and one for ray tracing. This would help us add even more types of renderers in the future. I'm going to keep the renderer protocol simple for now. It will conform to mtkViewDelegate and hold the max buffer's in-flight variable. This variable decides how many frames the CPU would compute before waiting for the GPU to finish with the first frame. The sample project used an observed object, but I'm going to use that observable macro, as this is the latest recommendation from Apple if I remember correctly. There were performance and other issues with observed object. Okay. Let's get our solid renderer hooked up to the renderer protocol. This renderer will just draw the solid shapes, without materials or textures. Think of it like the basic unshaded look in Blender's edit mode. Just the raw forms. Okay, I guess we can define the command queue in the protocol as well. I just realized these were specific to the sample project I downloaded and not required for rendering the metal view. Let's get rid of all these then. I will also be using guard instead of iflet here for cleaner code. I usually prefer to use iflet only if it's gonna encapsulate just a few lines. Alright, after a ton of cleaning and refactoring, we're down to the core code. I am feeling good about this. Let's run the app, and it crashed. Of course it did. It never works on the first try. Oh yeah, I forgot to initialize the engine. But hey, we got there! And look, a totally empty black window. I know. Not exactly the most thrilling visual, but trust me, it's a big deal. We've got the groundwork done, the canvas is prepped, and now we're ready to actually start putting some stuff on it. So definitely don't miss the next video, because that's when we'll be diving into getting some actual shapes and colors popping up in this metal view. Things are about to get way more interesting than just a black screen. See you then. Cheers.